So this is a short video explaining the theory and principles behind the tangent to an ellipse. So we have our ellipse, which is black in color, and it's this one here. We also have a major axis which goes from this point to this point here. We also have a minor axis which goes from this point and this point here. Now we're going to need these major and minor axes when we're constructing the ellipse using the concentric circle method, but that's a different story altogether. So we also have two focal points, which is one here and one here. Now to get to focal points, all we do is we take half the length of the major axis, which is basically from this point to this point, and we scribe an arc from the minor axis. So that gives us a point here and a point here. Now to find our tangent, it's really simple. All you do is we join the two focal points up to any random point along our ellipse. So we'll say this point here. So we join this focal point up to this point and this focal point up to this point, and that makes an angle here. So you can see, let's just say this angle here measures 106 degrees. So what's this angle we're talking about here? Now what you do is you bisect this angle, and that'll give you this line here. This line is called your normal. Now when we find our normal, all we do is we go perpendicular to it until we find one point of contact with the ellipse. Now we know the tangent always has one point of contact with the ellipse, because any other point would be, if it's more than one point, it would go through the circle and would be called a secant. So as we can see, as you move the point anywhere along the ellipse, like so, we can see that no matter what, they're always going to join back to the focal points. So no matter what angle it is, it's always going to be the bisector. Your normal line is always going to be the bisector, or the angles your focal point lines make. So we can see that there. That's also key to notice when you extend on your focal point line here and you go parallel to your normal line from this focal point, it makes a point here. So we can see that this line, and this line, and this line, and this line make two equiangular triangles. So no matter where we drag the point back along the ellipse, these triangles are always going to be the same area. They're always going to be equal, no matter how big or small they are. Also this line is also going to be the same as this line, no matter where the point is. So you can drag it anywhere along the ellipse like this, and you can see that they're always going to measure the same. So that's basically all we have to know about the ellipse.